Thank you for your time. My name is Ali Reza Yagubi, and I'm the Chief Technology Officer at Airgo, where we try to develop technologies that enable more sustainable alternatives to metals. Now, at this point, you might have this question that why do we need to replace metals in the first place? There's the obvious benefit that metals are very heavy, and in every moving applications, for example, like electric vehicles, that weight penalty means higher energy consumptions. There are also some not so obvious reasons. In more recent years, we are seeing that industrial metals such as aluminum and magnesium, their prices are skyrocketing, and that's due to the fact that their production is highly energy intensive. China is the biggest producer of these lightweight metals, and because of recent environmental commitments by the Chinese government, they have capped the production of these metals. And that's what's really driving the prices of these metals higher and higher every day. So just before Christmas, we were looking at $2,600 per ton for aluminum. In 5 years, we'll be looking at more than $8,000 per ton. Magnesium is even worse, more than 200% increase in the last 1 year. There's already a large and growing market known as metal replacement. It's about $100 billion already today. And the idea is essentially you replace these metals with reinforced thermoplastics. And reinforced thermoplastics are not new. They have been around since the 1970s. They're very efficient. They're very fast to make. They do not generate any waste. They have low carbon footprint. The challenge is that in this special kind of composite materials, you have millions and billions of these small micron level fibers, which makes predicting the behavior of these components very complicated. So if you're a company today that is looking for more sustainable solutions, you have two choices: whether you have to invest in very expensive trial and error based development, or you can use conventional simulation tools, which is very resource intensive, and it will take weeks and months to run, which is most of the time not possible in an industrial setting. So, and that's where our technology comes in. We have developed an AI-assisted platform that uses micromechanical calculations and machine learning to speed up the whole process. So micromechanical calculations, they are very fast. They're pretty much can be done in real time, but they lack accuracy as compared to more conventional so-called homogenization-based simulations, where we use historical data coupled with machine learning to improve the accuracy of the calculations. And our AI generates up to 12 different functions that we use our software to map to the structural mesh. This is a quick example. This is one of the parts that we are currently mass producing for a customer in Germany, and this is a relatively simple geometry. But despite its simplicity, we have up to 6 million data points for this part. And the colorful images that you see here show how complex the properties of this part can be. So we are working with many customers across different industries. And our technology is industry agnostic, but the outcome is always the same. We're talking about a combination of weight saving, lower carbon footprint, and potentially even lower cost. You can see some of the examples here. We're currently working with companies like Kone to replace die-cast aluminum in escalator steps. And these are some of the other customers that we currently have. Most of them come from mobility, automation, industrial equipment, and consumer products. And we have a great team. We have Maziar, who had a successful exit before, sold his company in 2012 to Nokia. Myself, I used to be a material scientist for 4 years before starting the company. We have very high caliber advisors and investors, for example, ex-CEO of Airbus Helicopter, people from Tetra Pak, and I think a very diverse team that can tackle this issue. Thank you for your attention, and I'll be happy to take your questions now.